Up to now, much of your trig was done in degrees. This is a rather artificial unit to use, and it's really only for historical reasons. Back in the day, they thought a circle covered 360 degrees because that was all to do with the Earth and the Sun, and then a right angle was a quarter of that. Another convention that could have been used is one with metric units. These units are called grads, and you have a grad button on your calculator, and they are sometimes used in engineering. It's often used in land surveying, though it's a bit like maths, the actual conversion is done before you use it. But in grads, there are 100 grads and a right angle, which kind of makes more sense. Most often that's used in France. So a lot of formulas are defined only because the angle is described in radians. And when we come to calculus, we'll see how important that is. Okay, a radian is the angle subtended at the center by a radius on the outside. So what we're doing is we're taking this length here and we're running it around the outside of the circle, and then the angle between two radiuses, that angle is now 1 radian. So if we take twice that length there and run it around the outside, then we have that this angle in the middle here is 2 radians. And if we take 3 of these lengths and run them around the outside of the circle, then this angle in here is 3 radians. It's really important when we do calculus that your calculators are set in radians. At the moment, it's quite easy using your calculators to switch from one to the other. If you're mid-calculation, you can use the mode button and just switch to whichever mode you want, radians or degrees. But if you need to convert an angle that's in degrees to an angle that's in radians, let's take 69.783 degrees, then your calculator must be in radians. So you change it to radians to start off with. Then you're going to enter 69.783. Not going to enter the word degrees at this stage. Then you're going to use your shift, answer, and then 1. And then you should see the answer of 1.218. And that will be in radians. To go the other way, your calculator must be in degrees. Because that's where we're going. So change your calculator to degrees. Now we don't put in the rads at this stage. We type in 4.25 and then shift, answer 2 equals, actually you need an equal sign in there too, otherwise it doesn't work. And we should find that this time we get 243 degrees. And the little degree symbol will come up. You can do it the old-fashioned way just by remembering that 180 degrees is pi radians, so then 1 degree is pi over 180 radians, or conversely that pi radians is 180 degrees, so that 1 radian is pi 180 over pi. That's the way I always used to remember it before I got proficient on my calculator. You need to learn some common angles as fractions of pi. 30 degrees would be pi over 6 radians. 60 degrees would be pi over 3 radians. 135 is 3/4 of 180, so it would be 3 pi over 4 radians. 45 degrees, that's half a right angle. Let's look at 90. 90 is half of 180, and 180 is pi radians, so it would be pi by 2. 45 degrees is half of that again, so that would be pi by 4 radians, and obviously 180 degrees is pi radians. Look at what we know. The sine of angle A, the sine of angle A is the opposite, which is A. The sine of A is the opposite over the hypotenuse, which actually, if you look at it, is the same as cos B. But what do we know about B? B is actually equal to 90 minus A. So what we can say is that sine A is equal to the cosine of 90 minus A. That's just what I've written there, so I don't need to write it again. Okay, the cosine of A is equal to the adjacent over the hypotenuse, but that's actually the sine of B. So the sine of B is equal to the sine of 90 minus A. Similarly, we can fiddle around and we can find that the tan of A is equal to the tan of 90 minus A. Let's use some numbers this time. The sine of A is going to be, if A is 3 and B is 4 and C is 5, then the sine of A is going to be opposite over hypotenuse, so that would be 3 over 5. And the cosine of A would be 4 over 5. And the tan of A would be 3 over 4. Similarly for B, the sine of B would be 4 over 5. The cos of B will be 3 over 5. And the tan of B will be 4 over 3. Now something we need to think about is that the sine of 90 is equal to 1 and the cos of 90 is equal to 0. That means that the tan of 90 is actually undefined, because then what it really is it's 1 over 0, because it's the sine of 90 over the cos of 0, and we know that that actually doesn't exist. So all we can say is that the tan of 90 is infinite. Right, these are just calculator jobs. First one, sine of 60, 0.9063. Look up the cosine of 17 degrees, 0.9563. The tan of 50 degrees, 1.1918. Now here, there's no symbol, there's no little circle, there's no R, and if that is the case, then we must be in radians, so we need to look up, change our mode and look up sine of 1, 0.8415. The cosine of 1.5 rather is 0.07, and the tan of 0.5 is 0.546. We need to extend the usefulness of this a little bit. What we need to be able to do now is, we already know that if we have the angle, we can find the sine of it or the cosine of it or the tangent of it. But we need to be able to work the other way. So let's say we've got sine theta equals x. Then what we can also say is that theta equals inverse sine of x. Or we could call it arc sine or something like that. all we need to know here is, are we in radian? Is the question couched in terms of radians or is it couched in terms of degrees? That will be what we'll set out. So the first question here, we need to have our calculator set in degrees, and using your shift sine button, that gives you the inverse sine. The inverse sine of 0.8 is 53.13 degrees. The inverse cos or arc cos of 0.2, 78.46 degrees. The inverse tan or arc tan of 1.3 is 52.43 degrees. Now change your calculator to radians and then find the inverse sine of 0.63, which will be 0.68. The inverse cos of 0.25 is 1.318, and the inverse tan of 2.3 is 1.16. It's all very well looking at the trig ratios where we have a right angle triangle like that. If we were to put it into the quadrants, into the Cartesian plane, but we're going to have angles that are going to be a lot bigger than that. So we need to know in terms of what they call a projection. So in the first quadrant, quadrant 1, the horizontal projection is positive and the vertical projection is positive. And in quadrant 2, the horizontal is negative and the vertical is positive. So that means then that if our angle is in here, so if we then, because remember we have to measure it all the way around, in this case cos theta would be the adjacent. Now the adjacent is negative over the hypotenuse, so it's going to be negative. It's going to be a negative number. And we can do that. We can find cos theta, tan theta, sine theta for every angle, every quadrant, and then we just need to work out the sine. You can work it out each time if you want, or you can remember if you want to that in quadrant 1 everything or all of the trig ratios are positive. In quadrant 2 only the sine is positive. In quadrant 3 only the tangent is positive, and in quadrant 4 only the cosine is positive. There are lots of ways you can remember that. I've always tended to remember it as being all science teachers count, where this tells me that all the ratios are positive in quadrant 1, that sine is positive in quadrant 2, the tan is positive in quadrant 3, and that cosine is positive in quadrant 4. However you remember, it doesn't matter as long as you do remember. Just some things to remember, and this is based on the quadrants, that sine in quadrant 1 is going to be the same as sine in quadrant 2, which means that the sine of theta is going to be the same as the sine of 180 minus theta. But for cosine, this is positive here, cosine is positive, but in the second quadrant cosine is negative. So in the first quadrant it's positive, so it's a right angle triangle. In the second quadrant it's negative, so the cosine in this quadrant, quadrant 2, is the negative of the cosine of the angle in quadrant 1. If you are talking about a rotation of 360 degrees or a multiple of 360 degrees, it makes no difference. You imagine if you spin yourself around 360 degrees, you're back looking exactly the same place. So it makes no difference to the sine or the cosine of that angle, adding or subtracting 360. For tangent, adding or subtracting 180 makes no difference to the tan, because that's how long it takes for tan to. We need to be able to use these trig ratios to give us different information. Suppose we need to find theta when the sine of theta is negative 0.4638. We can see on the graph, I know we haven't looked at sine curves yet, but if we had drawn the graph, then what we'd be looking for is the numbers here that will give us the x values, so that when the sine of theta is negative 0.4638, what corresponding on the x angle? Is it and what is it there as well. Now you can already see the answers, but let's just pretend we can't. Right, we are in degrees, so you need your calculator in degree mode, and probably the best way to do it is just to forget the sine for the minute and find the sine inverse of 0.4638, and that'll tell us that theta is equal to 27.63 degrees. However, we're looking for negative there. So we need to ask ourselves, where is sine negative? And sine is negative in which quadrants? It's negative in quadrants 3 and 4. So we just draw our little diagram, our little butterfly diagram, just so we know where it is. Right, in quadrant 3, so our angle would be there. It would be, theta would be equal to 27.63 plus 180 degrees. And if we're in the fourth quadrant, theta is going to be 360 minus 27.63. And if you look at the answers that are given, those are the two answers there. Again, our calculator needs to be in degrees because we're told that theta is between 0 and 360. So we need to find that, we need to find the inverse tan of 1.7629. So tan inverse of that, and if we look that up with our calculator in degrees, we find that that's 60.44 degrees. Now it's positive. Where is tan positive? Tan is positive in quadrants 1. So all science teachers count, so it must be in quadrant 3. So our first angle, that's fine, it's in quadrant 1. Now we need it to be in quadrant 3. 1, 2, 3, so it needs to be there. So it would be 180 plus 60 degrees. Again, let's just do this one without the sine, and let's find theta or alpha, doesn't matter what you call it, let's just call it alpha to be a little bit different. So alpha is going to be cos inverse of positive 2348. And if we're in degrees, we can look that up as being 76.42 degrees. Now, where is cos negative? Cos is negative in quadrants, let's remember, 2 and 3. So, quick sketch. So, in quadrant 2, then we're going to be 180 minus 76. Or in quadrant 3, it's going to be 180 plus 76.